All right. Hey, everybody. I recognize a few of you. Okay, we're going to go ahead and get started. Thank you so much for coming to my talk. I appreciate it. I realize that you're gifting me some of your time, so I'll try really hard not to waste it. My name is Kent C. Dodds, and I like React a lot. This is some information about me. I work for PayPal. I live here in Utah, and I've got a wonderful family and a dog, which I guess is part of the family. And this is a bunch of stuff about me, but I'm not going to explain it all. I have a link to my slides at the bottom here, kcd.im/simply-react. And you can get all the stuff here that I'm going to talk about from that. Okay, so some of you are here for my last talk, and some of you are not. So for the benefit of those who are not, I'm going to invite everybody to please stand up. Come on, yeah, this is great. We all love this. Your body's going to be like, twice in one day? Oh, my. Okay, so put your arms out in front of you like this. Squat down and back up. Yes, this is good. Okay, we're going to do 12 of these together, air squats. Count out loud with me. Ready? 1, 2, 3. You're doing awesome. 4, 5, 6, 7. So good. 8, 9. Okay, I'm starting to get tired. 10, 11, and 12. Okay, great. As I break the mic, before you sit down, stretch up high over your head, as high as you can, and then higher, and then over to one side, over to the other. Awesome. Okay, before you sit down, turn the person next to you, shake their hand, thank them for coming. All right. Okay, cool. I think physical health is really important, an important part of well, it's an important part of life. So we should all just be healthy, exercise, it's good. I don't do enough of it. This is actually the only time I exercise is when I speak at a conference. That's why I try to speak so much. No, just kidding. Yeah, awesome. Thank you for indulging me. So I'm going to start out with some expectations here really quick. This talk, we're going to go through a typical component lifecycle example. This is not what you're thinking. We're not talking about React component lifecycle. We're talking about the lifecycle of the component. Ha. We're going to talk about patterns that we can use to simplify our components, composability, and I'm going to give you a challenge at the end. You didn't know there was going to be a quiz. I hope you brought your number 2 pencil. Just kidding. There's not going to be a quiz. I'm not going to talk about how to implement these patterns. Okay? We're just talking about what these patterns are and why you would care to look into patterns that can simplify both the implementation and the API of your components. So for those of you who are here who are pretty new to React, some of the things that you hear here might be a little bit foreign to you, but lots of the things will be useful. If you are new to React, or even if you're not new, people have told me that this course that I have, it's absolutely free, is really helpful at understanding the fundamentals, and I think understanding the fundamentals of React are like paramount to being able to implement and use these patterns effectively. So I like to reference this. Also, if you are experienced with React, you want to level up, then this is not free, but it's my Advanced React Component Patterns course on Egghead, and I'm giving it as a workshop online, actually, live in like a couple weeks. So it's on workshop.me. You can go check that out. But people have told me this is really helpful, and I teach all of the patterns that we're going to be looking at here. I teach all of them in this course, so you can learn about the how. So we're going to talk about the why then. So let's go ahead and jump into it. Okay, this is an accordion. Pretty standard. You probably built one of these before. If you haven't built one of these before, you probably will one day, or at least you'll use a library that implements this this type of UI. But you have a title. That title might change based off of the open state of the accordion. The accordion items each have some contents, and then it expands, and maybe there's a neat animation and things. So this is like a basic implementation of an accordion, and that's the component that we're going to be talking about. So when you implement this the first time, you're probably going to build it like this. You'll have a component called Accordion, and it will take a prop for items. And then it will implement all of like how things look, and you can have all of the component or all of the items be passed in. The item will have like a title and contents, and then you just render the title where it's supposed to go and the contents where that's supposed to go. Okay, so that's pretty simple. This is probably how I would implement it from the very get-go. But here is where we get into the life cycle of a component. It never stops here with reusable components, almost never. If you want to build a component that you're going to be using on multiple pages and you're working with teams and stuff, eventually somebody's going to come to you and say, hey, we want to use that same Accordion component that you built over here. Can we maybe refactor it or something a little bit so it can be shared and used by both teams? And you say, awesome, yes, that's great. And they implement it, and then they come to you and say, hey, we've got a slightly different situation. Our designer wants things to look a little different. So for us, we want the contents to appear above the Accordion, right? So you think to yourself, well, that's kind of weird, but I guess if you need it, then we can make that work. And so I'm going to add a prop to my component API that's above is true. Okay. So awesome. Now we're sharing code, and that's the idea. Like that's one of the things we love about these components, right? Is the ability to encapsulate some logic into something that's reusable, and like you just have a couple of these props to change how the behavior of that, or what the behavior of that component is, or how it looks. So then you get another project that or another feature that you're going to build, or some other team comes to you and says, hey, that's awesome that it can do above and below. Could we have one that goes to the right, like so my items appear on the right side? And you say, yeah, I just like add another prop, right is true, and now I have another, so I already have an if statement or like some weird ternary in my render method, so I'm rendering things in different places. I'll just have it rendered a little differently. We're using CSS grid, and so it's actually pretty easy to regrid these things, and it's not a big deal. Okay, so your render method's starting to get a little bit more complicated, but you can support 3 entirely different use cases, so that's awesome, right? Now we're sharing this across 3 places. Well, then what happens is somebody says, hey, I want it on the left side. Like, okay, some more logic in your render method. That's fine, whatever, we can do that. So when things start to get a little bit more complicated is when it's more than just the way things look, but it's also in the way things, oh, sorry, and then you have a left true. Sorry, I jumped ahead of myself. But then you're like, hold on a second. This guy on Twitter named David, I can't remember his last name, but he goes by David Piano, but that's not his last name. Anyway, he's like, hey, make impossible states impossible. And you're like, yes, sir, David, I will make this impossible state impossible. And now we're, instead of a left, right, top, and bottom, whatever, we're going to have a position prop. Because you couldn't have a left true and a right true. That's an impossible state, right? So you want to make that impossible. So we're going to change this to a position prop now, and that makes it better. So yeah, now things get more complicated when somebody comes to you and says, hey, I think it's great. Your default behavior was totally, or the default look and feel is totally fine for my use case. But what I need is, it needs to behave a little differently. So the user can only open one thing up at a time. Okay? If they try to open anything else up, then it closes the previous one that they had open. Okay? So user of your component. Because what we're doing is inversion of control. We're saying we're not in charge of rendering, you're in charge of rendering, and you just render whatever you want. We'll take care of managing the state for you, and you take care of rendering. And by doing that, we can support a ton of use cases. So let's look at a couple examples. So this is our standard accordion, what you were looking at. We have some shared things for styling purposes and things. But we're just rendering that accordion. And as a child, it's a function. And you have your open indexes and the handle item clicked, so the state and a mechanism for updating the state. And then you render whatever you want. So it's totally your choice. For us, this is the standard one. So this is accordion title on top, and then the contents come below. That's pretty standard. So we're taking all the items that were passed to the standard accordion, and we're mapping over those to create an accordion item. And then we have an accordion button and the accordion contents. And that's all just like style abstraction stuff. You don't really, like it doesn't really matter all that much. And we just determine whether or not that button is open based off of our state that we're getting here. And then when that button is clicked on, then we'll say handle item click, and we pass it which index was clicked. And so with these 37 lines of code plus, I didn't count these lines of code, it's probably like 15, 20, we get that standard first example that we saw. Let's see if we can, no, still nothing. So, so that's cool, but what if I want to support, like, you know, remember we had a bunch of different use cases that we want to support, and now with that 37 plus 20 lines of code, whatever, I only support one use case. Well, here's the cool thing with designing your components this way. Somebody comes to you and says, hey, I need the contents to come above, and you say, that's awesome. Take this standard accordion, duplicate this code, and literally move accordion contents above, and you're done. And that's all that you need to do. I would much rather duplicate, like basically duplicate 20 lines of code than have to make an implementation of a component more complex. And actually, what's kind of interesting is we could add that capability to the standard accordion as well. We could just like make the standard accordion more complex to support that different use case without making our base accordion more complex. So we have that composability win. And then what if we want to do it to the right? Well, we take that standard accordion and we're using CSS grid, so it's actually pretty easy, just a different CSS property we're applying to that. If we want to prevent a single close, this is where the state reducer pattern comes in. We can take, we specify a state reducer, and we're going to say single and prevent close. And you can look into those implementations there. This is mostly just to show you that this is possible. But anytime the accordion says, hey, an item's been clicked, let's set state, it's first going to call into your state reducer function, and you have an opportunity to make adjustments to how that state is going to be updated. That's the state reducer pattern. That's what that enables. And so you don't have to add complexity to your handle click in your accordion. The user will opt into that complexity when they need it. And writing these kinds of reducers is actually fairly trivial. And this is something that I probably should have mentioned earlier. These patterns are things that I have built open source libraries using, and it's been wildly successful. I've had to change very little about the API once I added lots of these patterns, because somebody says, hey, I need you to support this, and I say, actually, you already do. You just have to do a little bit extra work to support that. And now we know. Now everybody's not paying for that use case, just the people who need that, and they're happy to pay that cost. So to move from a cool aspect of this is because of React's composability model, we could actually take our accordion, our standard accordion that that's using our accordion, and actually compose another layer on top of that to make a tabs component. So we're taking that accordion, we pass this state reducer that will prevent close and only render a single one at a time, and then we forward on the rest of the props. And from there, I can make a standard tabs component, which will render the tabs. And I don't need to worry about the state reducer or anything like that. I just say, okay, tabs, do your thing, and tabs is using accordion under the hood. So the tabs component is like 10 lines. And then from that, I have total control, and I can render I iterate over the items to make my buttons, and then I iterate over the items to make my tab items. And then if I want to, somebody says, hey, I want to render that on top, below, or whatever, then it's literally just like copy paste this and move it. That's all that you need to do. I'm almost finished here, actually. So, and if this demo, yeah, sweet, it finally loaded. I'll show you like when we're all done. Here, I'll refresh the actual code here too. So just a word of caution about using patterns like this. It does add complexity. The implementation of that accordion component, they're like that internal set state method and things, like all of this is abstraction. It's all adding complexity. So what if this is all that you ever need. That's all anybody's ever going to use. And you've gone through all of the work to make this highly flexible component. It's more complicated than you need it to be. So don't try to solve problems that you won't ever have. So if I were going into this and all I knew at the present moment was that we needed an accordion that behaved like this, that's the accordion that I would build. And only after I get a couple requests to enhance its capabilities, that's when I start to think, okay, let's redesign this component a little bit, release a 2.0, and now I can support all these things. So yeah, don't try to solve the entire world with your accordion component. So there are more patterns that can really simplify your API that I've shipped to production in open source libraries and in like application components as well. It's not actually just for reuse. It's also great. These patterns are great mechanisms for separation of concerns to simplify building these applications. So we looked at render props and state reducers and how those simplified the accordion to make tabs and render things differently. There's also compound components. You could actually take these two patterns, render props and state reducers, and build a compound components on top of that. And control props, even more powerful version of state reducers, even though it's puts a little bit more effort on the end user. The provider pattern, which is now built into React with React Create Context. There's a ton of stuff that you can do. And what's really exciting to me about software is that lots of this stuff is just like things that we learned 20 years ago in computer science and are just rediscovering and applying in the new context of the world that we live in now. So this is the challenge. I want us to rediscover or to discover more of these patterns that we can use to simplify the API and potentially the implementation of our components. And that's all I have for you. Thank you very much. So this was supposed to take an hour, and I knew it wasn't going to. An hour is like way too long for one person to talk in front of everybody. So I can show you the implementation of some of this stuff if you're interested. If you're not interested, feel free to get up and walk out. I will shield my eyes so I don't even know who you are, because otherwise I will cry and be sad when I see you next. Just kidding, I won't. Yeah, so here are some of the demos that didn't work. So you have your standard, opens all of these. And then the above, and that's kind of fun. And then left. And you'll notice, like, maybe you didn't notice, but the hand actually changes direction, which is a nice little touch. And then right. Oops. And single, only one open at a time, but you can close it. And then I prevent close. I can't close this one, but now I can because another one's open. But I can't close that now because it's the only one open. And then a single prevent close. So I can't close this. I can't close it. A combination of the previous two. And then that's what a tabs UI is. So we've got our tabs and above tabs. Okay, so those are all the examples. Let me just get rid of this thing. So here are the items, and we're rendering all of these examples. These are intentionally like duplicating code. I could, and I think I have an example in here where it's one component that does all of these things. It's probably old stuff. Oh, it's not actually. I'm sorry. Yeah, you probably won't be able to see this very well. Let me bump that up a little bit more. Hopefully that's sort of helpful. Sorry. Yeah, I don't think they have that feature. Total bummer. Sorry about that. Is this even helpful at all, or should I just not even show? It's okay? Okay. Okay, cool. So here's our accordion. You saw this earlier. It is 55 lines of code when it's formatted nicely. Yeah, as far as the implementation is concerned, and I actually show you how to do all of this stuff in my course. So it'll probably make a little bit more sense. But the crux for the UI portion of all of this, what makes that flexible, is this render method that basically does nothing. It gets the children prop and it calls that with state and a method and some mechanism for updating the state. And it could be multiple mechanisms. In downshift, for example, my autocomplete library, there are a bunch of different things. You can say like toggle open to open the dropdown, or highlight item, or select item. Lots of different mechanisms for updating the state. And so yeah, that's by using a render prop API, it gives you total flexibility over how things look. As far as how things behave, from there, you have this internal set state method. This is how I implement it. This is implementing the state reducer pattern. So, and by the way, so I'd never seen the state reducer pattern in React before, but apparently it's used in React Reason. Reason ML is this other language that's really amazing, and I want to learn it, but I don't know it yet. But apparently they use, every component has a reducer that you can provide to change how its state is managed. So that's some validation for you. It's not just some like weird idea that I came up in my brain. But yeah, so instead of calling set state, you call internal set state. You do whatever normal thing you would do when setting the state, and then it can be useful to provide a type. And I'll show you why that's useful later. So you provide, just like a regular set state call, you're passing a function, you return the state you want to have changed, and that's what this open indexes is. And then the type is useful for people using the state reducer. Then we'll call this internal set state. That's going to get called with the changes and callbacks, so it reflects the same kind of API that set state provides you. And here we're going to say if the changes that we're passing as a function, then we'll call that function with the actual state, which we get from this dot get state. Let's see. Oh, actually, sorry, this is also implementing control props, which we didn't talk about. So pretend that all this says is this dot, pretend actual state is just state. Don't worry about it. So in any case, you have the state at this iteration during this batch of set state calls. And then before we return the changes that we want to have, which right now it is this object right here, we're going to call into our state reducer, the state reducer prop. If that's not provided, we'll have a default that just returns the changes. So we call it with state and changes. So if it's not provided, it's just going to take our default, whatever we're actually returning. But if it is provided, then that gives people an opportunity to take the actual state and the changes object and make changes to that. They can return whatever else they want. They say, you're saying that you want the open indexes to be these two. I'm saying I only want it to be this one. And so whatever they return is what we return. And that's how state is managed internally. So lots of people are a little bit concerned about this because it's like breaking encapsulation. Part of the nice thing of components is that it encapsulates logic. Yes, it's breaking encapsulation. And yes, that can be a problem. But no, I don't think it's a problem. Because now we just consider our internal state to be part of the API. And by doing that, we open this huge amount of flexibility for users of our components. So I'm happy with that. So anyway, once that's all finished, we call this onState change, so you can listen to changes that are happening, and then the callback. So that's the implementation of the Accordion. It's implementing our state reducer. It's actually implementing control props as well, which I don't think I have any examples of actually using that. That's kind of funny that I did that. It just kind of came naturally. They integrate together pretty well, so that kind of came naturally. And then it implements the render prop API. Any questions about the implementation before I see other stuff about this? Okay, cool. So then we have our Accordion, and we'll just look at the standard here really quick. So with this, because the Accordion is managing all the state, we don't need to, it can just be a function component. And even with the single prevent close one, here actually, no, I'll just show this one. It is actually doing some state management, but it's using this combined reducers and the state reducer API to manage that state, which I think is kind of neat. But yeah, so because it's calling our children prop as a function, we can accept the open indexes and handle item click. That's an object that we get as the argument to this function. We're destructuring those out. And then we return the JSX or the React elements that we want to have rendered when that happens. And then I think the last thing to show you is this combined reducers and these different reducer things. So the reason that, let's see, right here, the single just provides single as the state reducer, where single and prevent close provides this combined reducer with the single and prevent close. Okay, so let's take a look at that really quick, and then I think I'll be all done. You can ask questions and stuff. So aside from a bunch of creating components for styling purposes and stuff, we have this single. So a state reducer is a function that accepts all of the state and the changes that the component wants to make to the state. So it's suggestions. It's like, if all other things were equal, this is how I would change the state. And so here we can say, if the type is opening, well, we're the single reducer, so we don't want them to open like anything else if there are other open indexes. So when an item, or when I click on an item to open it, what it's going to do is add that index to the end of the open indexes array. So every single time we're opening something, I'll just take that open indexes array and slice off just to grab the last item. So even if they're opening just one, it's always just going to get the last item. If they're opening a second one, it's going to grab the last item, and that's always going to be the one that will be open. All the other ones will be open indexes, will not include any other indexes. So that's how the single works. The prevent close will say if the changes type is closing and there are less than 2 that are currently open, that means you're going to close the only one that's open. So I'm not going to let you do that. So I'm just going to return null. And we're just not going to change state. We won't re-render. Don't do anything. Just ignore it. Otherwise, we'll just return the changes. Like, you're fine to do whatever else. I don't care. And then combined reducers is a little bit more complicated. It itself is a reducer, state and changes. And then for all the reducers that you've passed me, I'm going to call it. And if the result is not equal to the original changes, so it's this reducer has actually done something, then I'm going to return that result. And that's what combined reducers is. So anyway, kind of fun stuff. I had a lot of fun making this demo. And I hope you had a lot of fun watching it. That's kind of cliche, but there you go. What questions do you have about my talk? Yes?
I'm just wondering, how would you compare these strategies that have shown us to one of the only strategies I have used in React, which is higher order components.
Sure, yeah. So you're asking about higher order components. How does this compare? Higher order components are kind of useful. They're a little tricky to implement. React has made it a lot simpler. So now you can implement a higher order component in just a couple lines. But it is, still the implementation details of them are a little frustrating. They're categorically less flexible than like a render prop or a state reducer because the composition model is static, meaning you have to create the component before it's rendered. Whereas these transforms of state or the transforms of like how the render works, that can happen like during the regular life cycle of the component. And that's the major weakness that higher order components have. A strength that higher order components have is that you can encapsulate a whole bunch of stuff just behind one little function, and it can just have like be at the edge of your module or like at the root of your module. No indentation problems or anything. And so people like them for that reason, but they are like objectively less flexible than these other patterns. So what I always say is if you want to expose a higher order component, then create a render prop and then use that render prop component in your higher order component. And so you can have both. You can't go the other way around. You can't make a higher order component and then make a render prop out of that. It's not possible, just because the static composition model of higher order components. So, good question. Any other questions? All right, cool. Thanks, everybody.